When we're making measurements in the metric system, which came into Canada in about the mid 70s, I think I was in probably about grade 5 or grade 6 when this came in, so I am fluently bilingual. I can actually measure things in the imperial system, which uses things like feet and inches and yards and miles, pounds, ounces, and things like that. The metric system, on the other hand, doesn't use those, but you will still quite often see those measurements here still, especially if you do things like technology, if you're using things like lumber. Lumber is sold here in Canada 2 by 4 by 8, for example. If you go and buy what you use to build a wall, for example, it's 2 inches by 4 inches by 8 feet long. The interesting thing is if you actually measure it, it actually isn't 2 feet or 2 inches by 4 inches by 8 feet. It's actually only an inch and a half by 3.5 by 8 feet, which is kind of a neat thing, but that's a whole different story. Are based on these things called base units, and it really depends on what it is that you're measuring. If I wanted to measure how long something was, the length of a room, for example, if I wanted to know how far it was from Belleville to Toronto, I would be measuring something called length. And in the metric system, we use a base unit called the meter. And notice the spelling of meter, and this is a common one that quite often people will kind of mix up and get backwards. It's METRE. The symbol, and most of you again probably already remember all of these, the symbol for a meter in the metric system is the lowercase m. If I'm measuring the mass of an object, and mass and weight are two totally different things. Mass has to deal with the amount of material that's in an object, where weight actually has to do with the force of gravity acting on it. Problem is, in everyday words or everyday language, we quite often use those words interchangeably, but mass and weight are totally different things, totally different words. They have totally different meanings, but we use those words interchangeably quite often in every day. Mass of an object doesn't change based on its location, where weight in fact can. But in the metric system, the base unit, sort of the starting place, is the gram, which is a lowercase g. Volume, the amount of space an object takes up, the amount of area, litre. Here again, this is one of those ones that quite often people will have and get things backwards. So litre, just like in the meter, the R comes before the E. That's a really common one that people will sometimes get backwards. Capital L this time. Why it's not a little l like the other one? Have a feeling it has to do with the fact that if you wrote a little l, it may look like a 1. So just remember this one's a capital L. Time, if I want to measure the duration of something, it would be seconds. And for those that have done chemistry, or those that are doing chemistry, you'll know that quite often when you're doing calculations involving reactions and things like that, temperature is really, really, really important. But we don't use Fahrenheit, we don't use Celsius, we use what's known as the Kelvin scale. The difference between one unit on the Kelvin scale is in fact exactly the same as the difference between one gradient on the Celsius scale. The only difference here being that the Kelvin scale doesn't have any negative numbers on it. It starts at absolute 0, and you'll know, or you'll talk a lot more about that in chemistry. But its symbol is the K. And there's lots of other ones, but those are sort of the ones that we'll quite often see most often. We can combine those in order to make other ones. So for example, if I was talking about speed, speed really just refers to how long does it take to travel a certain distance, how much time does it require. So speed really is a combination of length of time and a distance. So the units there would in fact actually be something like meters per second. I'm taking a unit of length and a unit of time and combining that. I could also have something like kilometers per hour, a length of distance and a length of time. Again, combining two different units to form another unit. Volume, we had liters. We could have something like centimeters cubed. That would also work. A centimeter cubed is equivalent to a milliliter. So those little tiny blocks that you used to have in elementary school look almost like a sugar cube. That would be 1 centimeter by 1 centimeter by 1 centimeter. That's equivalent to a milliliter. Again, remember these are base units, and base units are starting points. And a lot of times the things that we measure are either way, way, way too big to use those base units, or way too small to use those base units. So that's where these things called prefixes come into place. And in the metric system, there's a bunch of prefixes that we use to help us if we're measuring things that are way too big or way too small. And these are just an example of a couple of them. There's lots of other ones, but these are sort of the ones that we'll see most often. And the ones that in fact we'll see probably most often with what we're going to be doing this year are the ones that are in this region here. The big M and the little funny looking U at the bottom we may see occasionally, but the ones sort of in the center section, that's probably the ones that we're going to see most often. And again, there's lots of other ones that are out there, but just so you kind of realize that those are prefixes. Again, remember with a prefix, all of those symbols have to be attached to something else. You can't use them by themselves. They don't make any sense. The base units, where it says base down here, that's where you would have like a meter or a liter or a gram. That's the starting place. The other ones are what gets attached to it. So the big M, if we're talking about a big M, what we're really talking about is mega. The big M is a prefix for mega, and that just really means that you've got 1,000,000 times more than whatever the base unit was. So if I had something like a mega, capital M, and a little m, which stood for meters, that really means that I actually have 1,000,000 meters. So that might be something like measuring the distance from here to something out in space. It's really, really far away. So saying things like I'm measuring it in meters wouldn't make a whole lot of sense, because you're going to end up with a really, really big numbers. But talking about things in megameters, that would make a little bit more sense, measuring something like that. Now we get into the ones that we're a little bit more used to. K, again, as most of you would remember, K, the prefix is kilo. Kilo, again, means 1,000 times whatever that base is. H, hecto. You now have 100 times more than whatever you started with whatever that base unit is. Hectograms, hectoliters. DA is deca. Deca is 10 times the base unit. Now the base unit doesn't have any prefix, so that's why there isn't anything there. Base unit is a starting point. Now we get into things that are smaller than the base unit. D stands for deci, is 1/10 of the base unit. So if I had a deciliter, I now have, if I now had a deciliter would mean I now have 1/10 of a liter, or 0.1 liters. I now have less than a liter. C, again, as most of you would remember, is centi. 1/100th of your base unit. M is milli, which is 1,000th of a base unit. Then you get into that funny looking U, which is the Greek letter mu. It stands for micro, and it would be a millionth of your base unit. So they're very, very, again, and there's lots more. If you take a look at the appendices in your textbook, it lists the ones that are in between, and they say there's more above and there's more below, but that kind of gives you an idea of the prefixes. Again, they have to be used with other units. You can't use the prefixes by themselves. They don't make any sense. So as an example here, if we had a kilometer, and again, notice M-E-T-R-E, sometimes we get a little bit sloppy with our pronunciations, and we say things like kilometer, but the proper pronunciation here is kilometer. So A being 1, a kilometer is 1,000 meters. If you had a milligram, that would be 1,000th of a gram. The nice thing about the metric system is, if you kind of look at the chart, it's all based on a factor of 10. So if you're going this direction, you're getting bigger by 10 each step. If you go down this direction, you're getting smaller by a factor of 10 each time, which makes doing those conversions a whole lot easier than the imperial system. Because the imperial system, it's a great measuring system, but you had some kind of funny little conversions and things. For example, in 1 inch, and most of you are kind of familiar with an inch, it's about the thickness or the width of a ruler. There are 64 64ths. In 1 foot, there are 12 inches. In 1 yard, there are 3 feet. In 1 mile, there's 5,280 feet. So you kind of have these numbers that aren't really very conducive for doing conversions and things for, whereas the metric system, because of the fact that it's all sort of tens, it makes it so much easier to do those conversions from one to another